Hi there, my name is Graham Lewis, and in this Inequalities 2 video we're going to look at some of the harder problems when we have a negative number of x's, because something funny happens with inequalities. I'm going to look at first something very simple, but actually not. Minus x is smaller than 7. Let's just remind ourselves how you'd solve that if it was an equality. Minus x equals 7. So if I'm looking at minus x equals 7, remember there's a hidden minus 1 before the x. We've got minus 1x equals 7. So there are two ways we can get rid of that negative sign. We could divide both sides by negative 1, or we could multiply both sides by negative 1. Both work. I've chosen here to divide both sides by negative 1 because negative 1 divided by negative 1 cancel, leave me with a positive 1x. And 7 divided by negative 1 is negative 7. So that's one way to solve an equality when we've got a negative number of x's. Let's have a look what happens when we do that idea with our inequality here. So I'm looking at minus x is smaller than 7. So let's say we divide both sides, that's a minus 1x, we divided both sides by minus 1. And I would get x is smaller than minus 7. Let's just test that though. Let's pick a number smaller than minus 7. So minus 7 on the number line is here, and I'm saying anything smaller. So minus 8 is the easy next small number, isn't it? Let's try. Let's look at the left-hand side. So the left-hand side here is minus x. And let's put minus 8 in. So I've got minus 8, because I'm swapping x for minus 8. And that equals to positive 8. So when I put x is minus 8 in, the left-hand side is actually equal to 8. And is 8 smaller than 7? And no, it's not. So this is actually wrong. And in actual fact, let's try a different number. Let's try a number which we think will not work. So let's try bigger than minus 7. Let's try 6. So now let's put into the left-hand side 6. So the left-hand side is minus x, and I'll put in negative 6. So let's try that. Negative 6, just swapping the x there for a negative 6. Two negatives next to each other make a positive. And now actually we can see that 6 is smaller than 7. So in actual fact it looks like this is completely wrong here, and x isn't smaller than minus 7, x is bigger than minus 7. So when we divide or multiply by a negative number, the inequality flips over. Let's just repeat that. When we divide or multiply by a negative number, the sign flips over. And we have to remember that. So here we go. Let's try this one. Let's try 3 minus 2x is bigger than 8. You'll notice here we've got a negative number of x's. That's why this one's going to be tricky. So firstly, let's solve it like normal. Let's get rid of the 3. To get rid of positive 3, we subtract 3. The sign will not change when I subtract 3, because it's only when I divide or multiply by a negative number that the sign has to switch. So subtracting 3 is fine. And the 3 minus the 3 cancels, leave me with, be careful, negative 2x. And 8 minus 3 is a 5. Now we're in trouble, because we want to get rid of this multiplying by negative 2. To get rid of multiplying by negative 2, we divide both sides by negative 2. But because I've divided by a negative number, we know the inequality sign flips over. So instead of a greater than, I need a less than, because I've divided or multiplied by a negative number. Now, negative 2 divided by negative 2 cancels, leaving with an x. And 5 divided by negative 2 is minus 2.5. Let's show that on a number line. So I'm going to show minus 2, and here's minus 3. Minus 2.5 is about here. I'll write it in. I'm not including the point, so it's hollow, and I want smaller than. Let's do our test. So now let's try left-hand side. So the left-hand side of my equation is 3 minus 2x. Let's pick a number smaller than minus 2.5. Well, minus 3 is a nice fit, isn't it? Let's see if it works. So 3 minus 2 times minus 3. So I'm just swapping the x number for a minus 3 there. Let's see what that comes out at. Minus 2 times minus 3, 2 negatives multiplied, make a positive. So I get 9. Okay. Let's have a look at the right-hand side of the equation, which is really simple. The right-hand side is just 8. And let's have a look. Our original equation said that the left-hand side has to be bigger than the right-hand side. So if the left-hand side is 9, is that bigger than 8? Yes, it is. 9 is bigger than 8, so we know we've got it right, and we were correct to flip the inequality over. Now it's time for you to try one on your own. So I'd like you to pause the video, try this question here, and then we'll come back and we'll discuss it. Don't forget to do a left-hand side and right-hand side check and show it on the number line. Okay, so pause the video and try this one. Okay, so hopefully you've had a chance to try this one. Let me go through it. So firstly, we want to get rid of the minus 5. We have to add 5 to both sides. Because I'm not multiplying or dividing by a negative, so the inequality sign stays exactly the same. The minus 5 add 5 cancel, which is what you want, leaving you with a minus 2x. And 7 add 5 is 12. Now we've got to remember the sneaky bit. This is a trickly trout, a sneaky snake, however you want to call it, a budgeling badger. I'm multiplying by negative 2. I'm going to have to divide by negative 2 to get rid of the multiplying by negative 2. Alarm bells! When you divide by a negative or multiply by a negative, the sign has to swap over. So I'm dividing this side by negative 2, and I divide this side by negative 2, and I remember to switch the sign. Minus 2 divided by minus 2 on this trickly trout becomes an x, and 12 divided by negative 2 is a minus 6. So I've got x is bigger than or equal to minus 6. Let's show that on a number line. So I'm going to show, all I need to show is minus 6. Because I'm including the 6, I'll colour in my circle. So that shows that I'm including the negative 6. I want bigger, do a scribble and an arrow showing that I'm bigger than minus 6. Let's pick a number bigger than minus 6 to test this. Well, 2, which is way over here, is bigger than minus 6. Let's choose that. So let's have a look at this left-hand side, which is minus 5 minus 2x, and let's throw the number 2 in for x. So I've got minus 5 minus 2 times 2. So minus 2 times 2 is minus 4. So I've got minus 5 minus 4. So I've got minus 9. Let's have a look at the right-hand side. The right-hand side is always 7. So is the left-hand side smaller than or equal to the right-hand side? And yes, it is, because minus 9 is smaller than or equal to 7. So we've got the answer correct. Okay, let's do one more. And I'm going to do this one in a different way for you. I'm actually going to do the same equation. Minus 5 minus 2x is smaller than or equal to 7. So minus 5 minus 2x is smaller than or equal to 7. In this method, I'm going to avoid multiplying and dividing by a negative. Some of you may like this method because you don't have to remember to switch the inequality. So this time, I'm going to make this a positive 2x by just adding 2x to both sides. I can't divide by minus 2 because that would flip the inequality, and I want to avoid that. But I'm going to actually add 2x to both sides so I don't have that problem. So I'm going to add 2x to the left-hand side, and I'm going to add 2x to the right-hand side. You can see what's happened. I've created a nice positive 2x, which I don't need to worry about. The minus 2x add 2x just cancels, and I'm left with a minus 5. Is less than or equal to 7 plus 2x. Now I have to subtract 7 from both sides to get rid of this plus 7 here. So add minus 7 from both sides. 7 add 2x minus 7. The 7 minus 7 cancel each other out, and I'm left with 2x on the right hand side and a minus 12 on the left hand side. Now I have to divide both sides by 2. 2 is a positive number. I don't need to switch the inequality. So minus 12 divided by 2 is smaller than or equal to 2x divided by 2. The 2's cancel as normal, leaving me with an x there. And I can read this left to right or right to left. If I read it left to right, it says minus 6 is smaller than or equal to x. If I read it right to left, backwards, it says x is bigger than or equal to minus 6. And that's a nicer way of writing it. X is bigger than or equal to minus 6. So it's actually at the end, when you read it right to left, you see that you change the inequality over, but just by reading it. And you can see that that matches beautifully with the same answer we got before. So this way is safe if you don't want to remember to flip the inequality when you multiply or divide by a negative. So you have a choice. You can either remember the rule, and you know why it works because I showed, or you can make the negative a positive by adding and subtracting. But remember, never, if you're doing it this way, don't multiply or divide by a negative. Okay, folks, that's it from me. Have a wonderful day. This was a trickly trout, this one, and I hope you enjoyed it.